Alrighty, cool. Yeah, so I guess we will start now. Obviously, we'll talk about last week, and then we'll move on to this week. Last week was pretty easy for the most part. I know we kind of talked a little bit about cookies, and we went through and did a bit of the stuff with cookies, but not very much. But don't worry about it because it's not. Cookies are kind of an interesting beast in the fact that while you will use cookies a lot, it's very rare that you set them on the client. It's more common that you will set them from the server. So next semester, when you guys have advanced frameworks, you will learn all about cookies because we'll be using cookies for authentication, and that's all done on the server. It is so much simpler to set cookies on the server than it is in the client using JavaScript. Way, way, way easier. It feels more like local storage, which, I mean, how many of you found local storage difficult, just out of curiosity? Yeah, it's not really, right? It's pretty simple. Works very well. That's why I added it to the assignment, because it's kind of like just free marks, because it's not really that difficult to use. So yeah, that's so don't get nervous about cookies. Cookies will not be on the test. Local storage will be, though. So just keep that in mind. All right, so yeah, we talked about self-describing data and client-side storage because these two topics kind of go together. We basically describe what is self-describing data. And we only really looked at two of the types of self-describing data that you guys have used self-describing data before. You can just think of it like a data storage, right? Any data storage you've used, if it's a good data storage, should be self-describing data, whether that's a flat file system, which I imagine you guys haven't really done that. But you have used SQL, right? MySQL and MS SQL, I'm assuming? Yeah. Have you guys used Postgres? No? Okay, but you've used MS SQL, right? In your ASP.NET class, probably? Yeah. Or is he using MySQL? He's using MS SQL? Okay. Yeah, they're all basically the same. Some of them have more features than other. My personal preference, if I have to use a SQL database, is Postgres, because Postgres supports JSON directly in the fields, and then you can query the JSON, which makes it really super powerful. So it's kind of like having Mongo, which is like a flat file type system or a document storage, NoSQL, inside your SQL, which makes it really, really powerful. So I really like Postgres. Plus, Postgres has larger capacity for number of records versus MySQL. So there's a lot of reasons why I like Postgres over MySQL. However, SQL is SQL, right? Once you learn how to query one SQL, it's pretty easy to pick up how to query the next one because they're basically the same. Most of the common queries you use are relatively the same. However, working with XML and JSON, a little bit different, right? XML, it's not bad. We kind of like it. However, at the end of the day, there are some issues with XML. One of the issues is we don't get data types when we work with XML. Everything that we have encapsulated is a string. None of it is numbers. None of it is objects. No arrays. Nothing like that. It is just a string. You can get some pretty interesting parsing systems that will at least parse out an array and understand that it is an array, and some that will even parse out objects as well. But for the most part, if you're working with XML inside JavaScript, the most you can really do is turn this into like a DOM and then work with it like a DOM, right? I mean, you're not going to see a ton of XML. If you work at a bank, you might. If you're working with a payment system and they're using Moneris, you might. It's only really in legacy systems. JSON has been around for 10 years. People like JSON because it's just easier to understand. It works exactly as expected. If you've worked with JavaScript objects, then understanding how JSON works is fairly simple. JSON just feels better. It supports native data types, every native data type to JavaScript except for functions. So it is a better thing. It just makes more sense as a data structure. It's kind of what you guys probably don't know what this is, but ORMs. Have any of you heard of an ORM before? Object Relational Mapper. So you know how you use SQL, right? Well, there's this thing called ORM that layers over top of the SQL database and gives you objects. So you can actually interact with your database like it was a bunch of objects. So say you had a table called students, you can interact with that thing by just doing like student.find 1, and it will go find record 1 in the database. ODMs are, once you start using an ORM, you'll never go back to coding raw SQL. I haven't coded raw SQL in over a year because I use an ORM all the time. It's just so much easier. But understanding how to query through JSON kind of makes that first step into something like an ORM a little easier because you get used to working with objects. Like I said before, you already know XML. XML is essentially it's HTML, right? They're basically the same thing. HTML is XML based. HTML describes its data, so you're already pretty much used to XML. That's why there's not going to be a huge amount of it. There might be a little bit on the test, but nothing really big. No querying or anything. Just probably write me an XML structure on this thing, and then you write it. It'll probably take you 10 seconds flat. JavaScript object notation, there'll be a lot of this on the test. So make sure you understand how JSON works, how you can actually build the structures. If you are confused about validating your JSON to make sure it's actually valid JSON, I mean, it's as simple as going to the internet and typing in validate JSON. Click the first link, which is usually JSON lint, and then just copy and paste your stuff in there and hit validate. And it will come back and tell you if there's something wrong with your JSON structure. It's not hard. I think the biggest things that tend to catch people on JSON is remembering to quote the keys. People tend to forget to quote the keys, and they need to be quoted in order to be valid. But like I said, if you put it in there and you hit validate JSON, it will tell you right away whether it's valid or not, right? So it's not really a big deal. The supported data types in JSON are strings, integers, floats, which fall under numbers, booleans, arrays, and other objects. Working with JSON data, identical to working with object literals inside JavaScript, right? And we've worked with object literals up to this point. I mean, it's identical to working with objects in general. You guys have worked with objects in Java, which are very similar to working with object literals in JavaScript. So it should be old hat at this point for you guys. What else did we do? We talked about converting JSON to a string and back for transfer. So that way if you're communicating JSON through like an API or something like that, you can convert it to a string, send it to its endpoint, and then they can decode it. And decoding JSON is actually something that's applicable in almost every single language. Like JavaScript obviously gives you native library functions for decoding JSON, JSON parse and JSON stringify. And it's interesting because in Ruby, you have JSON parse, the same, and in PHP, you have JSON parse, right? But then for actually converting it into a string, they have different methods. I think in Ruby, it's JSON, it's to JSON, and it will convert it to a string. And then in PHP, it's JSON.encode in order to convert it. Not that that's super important. The only thing we care about is that JSON is platform independent. It's agnostic to the platform. So you can transfer it from programming language to programming language, irrelevant of what those programming languages are, which makes it very powerful because, you know, I'm a JavaScript programmer. I code in Ruby and I code in PHP. You guys are Java programmers. You do a lot of Java programming. But our applications should still be able to communicate with each other, and we can do that through the language of JSON, which both applications speak. So that's what makes that cool. All right, we talked a little bit about recursive functions. As I promised, there won't be a recursive function on the test. There may be a bonus question that might include recursion. So if you want to like learn up on recursion, you could probably get some bonus marks. For anybody who needs them, I would definitely read up on recursion. But essentially, in the simplest of forms, recursion is a function that calls itself. That's in the simplest of terms. And then we got into client-side storage. We talked a little bit about cookies. I mean, like a very little bit. And then we got to the meat and potatoes of local storage, right? Local storage, super easy to use. You can do full CRUD in local storage, right? You can create by using set item. You can read by using get item. You can update by calling set item but passing the same key you passed originally. And you can delete by calling remove item, right? If you want to get rid of everything, you call clear, and then it's all gone. Three actually. Just three methods in order to do the whole CRUD operation. Was that basically it? Yeah, that was basically it. Cool. 13 minutes, not too bad. Any questions about last week at all? No? Did you find last week hard? Not really? Did you find JavaScript in general hard? No? Cool. I like your optimism. You guys are excitable today. All right, we're going to talk about working with APIs today. Something that's applicable to every language you work with. And incidentally, you guys have already worked with APIs. You may not even realize that you have, but you have. Quite a bit, actually. So, unfortunately, this is probably one class I tend to lose people in. They tend to fall asleep on me. I will try to be exciting as possible, but I mean, this is a wall of text. We don't get to our first actual interactive thing till there, and that's because we have to know all this stuff in order to get to that point. Just give me 1 second. I just want to clear my application local storage. Ba-ba-da. Clear. There we go. All right, my local storage is nice and clear. I'll refresh my screen. All right, working with APIs. Anybody know what an API stands for? Yeah. That's exactly it. Application Programming Interface. APIs. A lot of people are automatically like, yeah, I know APIs. Google API, Facebook API, Twitter API, right? Instagram API. But that's the thing. APIs are not limited to external resources, right? What those things are, they're called REST APIs. They're an actual paradigm. They're a concept, just like model view controller is a concept, or component-based programming is a concept, or that one that I always forget. It's over inheritance. Something over inheritance. Composition. Composition over inheritance is a paradigm. These are more like design patterns, right? REST APIs are design patterns. APIs, though, you guys have used them already. How many of you used the math library in Java? Right? That's an API. Okay. How many? Well, we've all used the math library in JavaScript, right? That's an API. Anytime you include a library into your application, you're using an API. Because what an API is, it's an interface that gives you ability to access a service of some sort. The service you can think of like a library, any library, right? When you want to be able to access that library and utilize that library, somebody builds methods in order for you to use that library. They give you an interface into using the library. When we built Simon Says, we used the audio context library. That was an API, right? Because in order for us to actually create the sounds and everything else that we needed to create, we had to be able to have an interface, some sort of way to access the methods, right? That's an API. So the cool thing about APIs is that they basically help us to not have to rewrite the wheel, right? That's the whole point of using libraries as well. They make it so that we don't have to rewrite the wheel. Somebody's already done it, and often when you're first starting out, they'll have done it better. Right? So it makes more sense to utilize things so you can do quicker development, even if you're just prototyping, so you can get it quickly up and running and then deliver it to whatever your endpoint is for review, right? So take a moment when you're building applications and go take a look out into the internet and see if this complex thing that you're trying to do hasn't been done already, and go see if there's a library for it, because often there already is. So APIs are really super important. But before we actually get into working with APIs, and more importantly, RESTful APIs, which is what we're going to be talking about, we kind of have to understand how a request and a response works in the internet. And to really sum this up at a very global level, we need to understand how the internet works. That's basically it, right? And some of you might be like, dude, I know how it works. I hit the little friggin' Chromie thing on my computer and I type in something and I get crap back. That's how it works, right? But there's so much more intricacies into what the internet is doing behind the scenes that when you understand that, you can now take advantage of those things and build some really cool interfaces for it. And that's where REST API comes into play, because REST API takes advantage of some interesting concepts about the internet in order to provide an application interface externally to people over the internet. So, like I said, when you open up your browser, you type in that wonderful URL, you're immediately connected into the World Wide Web, right? When you hit enter, what occurs is you actually wind up creating something called a request. Now, it's not limited to browsers, right? When you open up your Steam library and you go to actually access your games and to play and stuff, that creates a request. It validates who you are and goes through all that process. Same with Origin, same with any of those guys, right? Or when you open up Discord, Slack, any chat application you might have locally, again, that's a client making a request. All these things make requests and all these things receive responses. So understanding that process makes it a little easier to grasp what's actually happening through the internet. So when you actually make a request, what happens behind the scenes, so here's our browsers, right? We're going to make our request. Here's my request packet. That's what we're going to call it, a request packet. And the reason why we're calling it a request packet is because it isn't just the URL you typed and sent off. It actually contains other pieces of information that are very important to the endpoint. It's going to give a whole bunch of information to the endpoint so the endpoint knows what to do with it. So we type in www.google.com. That hits our request. In our request, we're actually going to have two pieces of information minimum. We're going to have a header that's going to contain the address that we're trying to locate, how we're trying to locate it, whether or not we're using get or post, right? Other pieces of information like cookies we might have, any authentication information we might have, and something called a request body. A request body will contain like parameters and stuff that we may have set. So all that information often goes through the internet, but before it actually gets to where it finally needs to go, that first line, that header line, gets checked with our browser cache. And I don't have that step in here. It's like right here is basically where the browser cache step is. And what the browser cache step does is it says, hey, this address you're asking for, this www.google.com, I'm going to take a look and see where that's located. Because in the internet, www.google.com means squat, means nothing, has no meaning to it whatsoever. Because we don't navigate internally through our network, through our internet, using names, right? We navigate through our network using something else. Does anybody know what it's called? How do we find other things on our network? What is the fundamental piece to get to another location on our network? Yeah, the IP address. So the www.google.com is just an alias for the IP address, right? In fact, it actually has a name. Does anybody know what it's called? What www.google.com would be called?
World Wide Web. No, World Wide Web.
Yeah. World Wide Web is the thing we're sending out to. This thing is known as a
Domain.
Keep going. Yep. DNS. It's a DNS. So the DNS, the domain that you actually create, that DNS, we have to do something called a DNS lookup, which is where we actually take the domain name and we compare it in a list. We use it as a key. And then we follow down and we go, oh, here's the key. And then we look beside it and there's the IP address. Because the IP address is what we need in order to actually create a connection to the server that contains Google, right? So here we are, we're ready. We've got www.google.com, and now we want to know where its IP address. And the first place we're going to check is our browser cache. We're going to say, browser, have I been here before? And do you already have the IP address? And the browser's going to go, yeah, we got it, because everybody Googles, right? So it's going to be like, cool, I've got it. And it basically takes your request and then now fires it off to that IP address where it can be resolved, right? If, however, your browser doesn't have it, it's the first time you've ever been to that address, what it's going to do next is it's going to keep along the chain and it's going to go to your ISP. Does anybody know what ISP stands for?
Internet Service Provider.
Exactly, Internet Service Provider. So, Rogers, TELUS, Bell, whoever you happen to be with, maybe you're with Starlink or Distributel or something like that, doesn't matter. It's going to go off to your Internet Service Provider, and they're going to take a look in their DNS lookup cache that they have, and they're going to see whether or not they've already resolved this address. Now, the cool thing about that is maybe I haven't been to google.com, but Lulu has, and because we are on the same ISP, they're going to find it because Lulu's already gone to that address before. So I'll get back that DNS IP, right? However, if nobody on the ISP has been to www.google.com, which is highly doubtful, but if nobody has, off we go to the DNS zone, right? Sounds like the Thunderdome or something. The DNS zone is responsible for containing a whole whack of domain names and IP addresses. The thing is because there are so many domain names and IP addresses, I think we're at like 9 billion now or something like that, over 9 billion addresses resolved. So because there's over 9 billion addresses, obviously we don't want them all sitting on one domain name server. That'd be quite a bit. That's why there's tons of them. There's tons of redundancy. They're all over the place. They use something called load balancers and stuff to be able to shift off requests. There's a lot of stuff happening in the background. But even more than that, it actually gets broken up. So the .ca at the end of the address, or the .com or the .net, .org, all of those are a fundamental piece of information because it tells it which DNS zone to go to. So if it's .com, off it goes to 2 cows, I want to say. I think it's 2 cows. Anyways, off it goes to the DNS zone that's housed by that, and they do a lookup inside there, and they go see whether or not that domain is there or where that domain was located last. Okay? So that's the next piece. We go to the DNS zone, we find out what route we have, and we go to the domain server that deals with that route, right, or route. And then from that route, we go off to the last place recorded where that domain existed. And if it's moved, that place will have a history in its records saying, hey, this address has moved. It is now located here. And then we go there. And finally, when we get to our endpoint and we get our IP address, our route will then go off to the server that Google owns, where Google actually has the thing we want, right? And it will parse our request and then send back a response. Along with that response, we're also going to get our IP address that we will now save to our browser cache, and our browser will cache that from that point on, so the next time we go to www.google.com, we shave off a millisecond. This whole process takes less than a second. In fact, if it takes longer than a second, you actually get penalized by Google for it, and you lose some SEO value if it takes longer than 500 milliseconds. So you want this whole process to go stupid fast, right? Which for the most part it does. It's very rare that it doesn't. If the address doesn't exist, that might be a reason why it would take a little longer, because it has to go through all the lookups, finally hit a point where the address no longer exists or the endpoint is gone, and then come back and tell you that the endpoint no longer exists, the server is missing, or server did not make a response, right? So that's the thing. So we have our request travels along the whole chain, blah, 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 blah. We finally hit this wonderful thing called the server, and we're requesting something from Google. For example, if we were to type in, I always like typing in boo. It gives me a little dog. This ridiculously adorable thing. I mean, look at that thing, right? That's the cutest dog alive. Anyways, look at the top here, though. This address that you see at the top, very hard to read. If you type it in your own browser, you'll see it. But you can see search $Q equals boo, and then there's a bunch of other pieces. Does anybody know what that thing's called? The pieces after .com / what that string is called, what the name of it is? What's that? Get parameters is close. Yeah, it's called a query string, right? So the query string is the things at the end, and you are correct in the fact that it will be using get. So it's using the get HTTP method in order to access this page. And our request, in the request body, will actually contain those parameters. And we can see that. I can show you. You can go to your wonderful network tab. Very handy place to be. You will have to, oh, sometimes you don't, but we're going to refresh our page. Cool. Drag this over a little bit. First thing is our search here, right? And there's our request. This is our request right here. You can see where the request address is pointing to. You can see what our request method was that we used. The request methods, there's a whole whack of them, but the two most common ones are get and post. Post you generally use for sending forms. Get you generally use for any normal requests that you make across the internet. The status codes, there's a whole whack of different types of status codes, right? Status code 200 means, yes, this is good. Good things have happened, right? Status 201 is good. Just means something a little different. I can't remember exactly what. And then there's the 300 series status codes. Does anybody know what the 300 series means? It's redirects. So I've come to this address, and they've redirected me somewhere else, right? Those are redirects. They're not bad either, as long as the endpoint resolves. And then there's the 400 series. 400s, are they good? No, they're bad. What do they usually mean? Yep, not found, forbidden, right? There's always a reason why you're getting the 400s. And while it might be their fault, it's generally a you fault thing. It's your client responding, the server responding, saying you've done something wrong. You've accessed a page that doesn't exist. You tried to access content that is forbidden to you. You've done something wrong, right? That's what it's basically saying to you. Then there's the 500 series. 500s, are they good or bad? How many people say they're bad? Yeah, and you'll be right. Are they worse than 400s?
No.
Oh, no, they are.
Are they?
Yeah, they're way worse. You as a developer, they're way worse for you because that means your server has, for lack of a better term, shit the bed. Something has gone drastically wrong with your server and it is now crashing and you need to go fix whatever the problem is. 500s, super bad, right? Very, very bad. 400s are generally user errors. 500s are generally you errors. All right? There's no 600s or 700s or any of those. Any other errors are generally custom that people have created. And that's one thing to note. This 200, while I'm getting a 200, I could actually be receiving a 40 for it because at the end of the day, the server responding responds with the error code. And they can change that error code. They have complete control over what that status message is and the status code is. And they can change it and make it whatever the heck they want. In fact, they have control over the whole response and can make it whatever they want. So there's no reliability here in this response. And the same can be said about the request. When you actually send a request off to Google or to anybody for that matter, you can also change information in the request as well and modify it to say other things. Like you can modify which browser it's coming from, what time you sent it, all this different information. So again, not reliable communication back and forth. Cool. So this is a response that we got back from Google. We're going to talk a little bit about response, but I wanted to get into the request headers. So here's the request headers. You can see we've accessed www.google.com using method get. This path contains our query string, but really it's just the path. The path is no different than any path, right? You can actually think of the path as the same as doing this kind of thing. Because it is literally the same idea. The only difference is instead of C:, we have HTTP:, right? Or HTTPS:, and then our path. So it's exactly the same idea. You can think of the directory as being like your domain, well, at least the first directory you're accessing. And that's because a lot of people get confused and they think the internet is some sort of unique thing that's magical just for the internet. But it's not. It's just a computer, right? It's a computer at the endpoint with files and directories and structures and stuff like that. And just like any device, you need to be able to navigate to wherever the file is that you're locating, right? When you locate an HTML file, it is a literal file with .html at the end of it. Just like CSS, just like JavaScript, any of those files, they are real files that exist on a server. They are a physical thing. Well, not physical. They're physical in the way data is physical, right? That exist on the server at the endpoint. And when you request them, it does resolve them and bring them back. Wow, that sun is insanely bright. All right. It's a little dark, but yeah, guess you're right. So yeah, this request header, there's a whole whack of different pieces of information. Look at the cookies. Look at all the cookies that get sent with that request, right? That's an insane amount of cookies. You got your language settings, your encoding settings, which are like gzip and stuff. I don't know if I get into gzip next semester. We might. But basically, it's a way of compressing CSS and JavaScript and images and stuff like that, make them a little smaller, a little bit more consumable. We have cache control. Cache control basically says how long should this resource last before I dump it and then generate new stuff for you and send it to you. It helps speed up your website, right? Because if you're accessing a cached version versus accessing the real version, then it makes it a lot easier. We have our refer. We have our upgrade insecure request, whatever that is, the user agent. So you can see I'm using a Mac, right? But again, this stuff can be spoofed. You can change all this information. It's not 100% reliable by any means. And then there's the query string, right? Look at all the different pieces in the query, right? That's the query string. It's broken it down. You can see this wonderful unreadable query string. It makes it readable. So you can see we have Q equals boo. Q likely stands for query, I'm guessing. TBM, who knows? Source, ICTX, FIR, VET, usage, CA, SA, VD. These are all like Google things that they like to do. Google doesn't like to use real terms, and they do that intentionally because so many people are out there scraping Google and trying to use Google search results as sellable information, like the company I work for, because that's exactly what we do. So Google tries to stop those people by making things a little harder to read and understand, so it's not so easy to grab it. However, they fail, and we still do. But yeah, so that's basically a request, what it looks like live. And you can see that in any website you go to. That is not unique to Google. That is every single website you go to, right? Whether you go to your own website, you go to YouTube, Pornhub, whatever it is you're going to. Those query strings, those request queries, they're all there. Everything is still there. It doesn't matter where you're going. Now, I did a nice little thing here. These have some pop-outs so that you can read them, give you a little bit more information on client and server. But that is the next step. So after our request is made there, the server is now ready to make a response. And it's literally going to go into its file structure, figure out what you're looking for, find it, and then return it back to you. And it's going to return a few different pieces of information. So it's going to give you back the status code, right? So 200 status code, that's a good thing. That means we got what we asked for. It's going to tell you the protocol it used to send it back. And there's a whole whack of different protocols that can happen. However, in the World Wide Web, the most two common ones you will see is HTTP and HTTPS, right? HTTP is just the basic old school protocol. HTTPS means it's a secure transfer protocol, which means they have an SSL certificate on the other end, right? That's a good thing. You want HTTPS sites, not HTTP sites, because they're protecting you. Or so they say. The date that you actually sent the request, the server that the request actually exists on, right? This one says Apache. Again, this stuff can be spoofed. We were working with this guy, and we wanted to just know what the system was, so we did a check on it just to see what the information was, and it said that he was using WordPress and all this other stuff, and it turned out all that was a lie. He was spoofing the information. He was using Joomla, actually, and a bunch of other technologies at the end. That were totally unreadable because he was spoofing the request information, right? Or the response information. You can get the last modified date, which will help you and your browser define whether or not it should continue carrying the cache for it. You can get accept ranges, the content length. This is kind of important because that's when the response comes back to you, that tells you how many bytes the response is and whether or not you want to consume that number of bytes. The connection is closed. All HTTP connections will be closed. However, if this was like WS, which stands for WebSockets, it will remain open. The handshake stays open until somebody kills their session. And then the content type, which happens to be in this scenario, text HTML. Then you get your actual response body, which will contain your content. Now, if it's HTML, it'll be raw text. If it's XML, it'll be in an XML format, and you should be able to read it. Same with JSON. You should be able to read the JSON. However, if it's an image, it will be in binary. If it's PDF, it will be in binary. So this can contain a binary response and come back as a binary response, which happens often, right? Like when you do, anytime you go to a website and there's a picture, hence right now, this is doing a request for an image, and the response will come back as a binary response. It is possible to get readable images, but they are usually base 64'd and then sent back as a base 64. So, like I said, the response packet contains two sections, a response header and a response body. The header contains a lot of information about the response. The status line tells the client the response's protocol version. So like HTTP, HTTPS, FTP, SFTP, WS, there's a whole bunch of different ones. SCP. The date of the status code and the status message. The date of the response, the last modified date, the content length, the content type, and that's only a few. There can actually be tons and tons of header information, including course policy information, accepted headers, authentication information, other cookies, other session cookies, stuff like that. You can get a ton of information back from that response. And then that leads into what are APIs? So the reason why this is kind of important to understand, not necessarily the response, though the response is kind of important to understand because we're so used to on the net always getting back HTML, right? That we tend to forget that our websites actually return more than just HTML. Quite often our websites return HTML, they return JavaScript. The same page can return JavaScript and HTML and CSS. All those can come back in one go, plus images, plus anything else. Any external link or even local link to that server is external to your client. So every one of those pieces of information has to make a request and come back as a singular request. They don't come back as a batch. It's not like it goes to the server and the server's like, yeah, no worries, HTML, JavaScript, a little bit of CSS on top, here's some images, wrap it up and send it to you as a combo. It doesn't work like that. Each one comes out as a separate request. That's why when you're doing web development, you want to try to make those as quick as possible so it happens smooth and fast, which it does. It does happen pretty quickly. So the thing is when we're using APIs, often your response will come in two different formats. One format is more common than the other format, and that's XML, right, which is very rare, and JSON, which is very, very common. So usually APIs, they will deal in those two formats because they can be consumed by whatever it is you're using at the other end as the consumption. Now, you might think, well, my client uses JSON, so it'll likely always be JSON. But it's important to understand that APIs aren't accessed just through the browser. Quite often, the API will be accessed by a middleware, which will then send it back to the client, or it might go through 2 or 3 machines before it finally gets back to the client. We're building this system called SCA, which is a smart content analysis system at work, and we're using Amazon for it. And we have this thing called a VPC, and inside our VPC is this whole network of computers, including all these little things called lambdas. Lambdas are singular functions. All of our communication inside this VPC is done with API, with JSON, actually, JSON parameters. And we communicate those JSON parameters through all of these different machines back and forth till finally we get a response that we build and then send back to our client. So servers themselves will communicate back and forth in languages like JSON or XML, once again, because it is programming language agnostic, right? I can communicate with a Lambda on my server that's written in JavaScript and a Lambda that's written in Go, and it doesn't matter. The two will communicate because the language in between is the same, right? It's kind of like learning sign language. If we all learn sign language, there'd be no communication issues, right? Because it's all the same. All right. So how does this apply to APIs? This applies to APIs because APIs are what we use in order to create that communication back and forth and request information back and forth. We also use APIs to write information. APIs, in the scenario that I'm talking about, like REST APIs, we use those to basically create CRUD with external resources. So we can now basically open CRUD operations across the internet. We don't actually need to worry about doing it through our server only. We can actually create little CRUD servers wherever we want and communicate to them using APIs. So often, like I said, we will want to use third-party data with our applications. APIs provide methods for us to access data. There are several types of APIs, though many people associate APIs with RESTful APIs. RESTful stands for Representational State Transfer. However, an API is simply a library, right, that you use, just like the libraries you use like math and the audio context library that we use, or any of the libraries you've used with Java or C++ or C# or whatever else you've used. RESTful APIs are used to promote abstraction from client and application. The idea, the cool thing about RESTful APIs is I can build a server that all it does is CRUD. Create, read, update, and delete. That's all it does. Just CRUD. Doesn't deliver me application pages, right? It doesn't actually give me any visual stuff whatsoever. All it does is deal with CRUD. Which means now I can build interfaces to interact with this application in anything I want. Doesn't matter what it is. I can do a web application, I can do an iOS app, an Android app, and they can all be built with different technologies, but accessing the same data through the same API endpoints, right? Which just makes it really, really fast, really, really cool, and definitely scalable, like very, very scalable. This type of API exposes methods to the client, public or protected, that allow the client to perform CRUD operations. The client can be anything that makes an HTTP request, but it's not limited to that. It's basically whatever you want to allow communication through. We have APIs that even communicate through SSH keys because we use SSH as authentication. RESTful APIs work by parsing HTTP headers and URLs to route methods and data back to the requester or send data to the responder. So we have these things called HTTP verbs or HTTP methods, which you guys would have learned a little bit in Rich's class. You guys wrote GET requests. Maybe you didn't realize you were writing GET requests, but every time you were retrieving back something from the server, whether it's a JavaScript file, CSS, image, whatever, those are all GET requests. Every single one of them is a GET request. In fact, forms, when you write a form, they by default do GET requests unless you tell them to do a POST request. You have to tell them to use the method POST in order to force them to use a POST method. There are a few others. There's put and patch, which is used generally for updating information on your server, and delete, which is usually used for removing information on your server. However, even though these four exist, and there's actually a whole bunch more, I think there's about 9 or 10 in total, the only two that are ever exposed to your client, your browsers, and that your browsers support natively are GET and POST. The W3C has been, pushed to try to include the other two, but doesn't feel that they're necessary. That being said, though, you need to be aware of them because frameworks, a lot of frameworks like Ruby on Rails, PHP's Laravel, Ruby Sinatra, Take PHP, any of those guys, even a lot of the ASP ones, stuff like that, they use all four. So you need to be aware that they exist and what their purposes are. So the server will look at the HTTP method verb used and the path that you request to establish which operation to actually execute. So this is the reason why that request is so important, because the request gives it a bunch of information. It tells the server what HTTP method you want to use and what path you're using to access the application's resource, right? Now the thing is in this scenario, we have this directory and we have this file, but at the end of the day, that's not 100% necessary. We can request instead C://method resource param, and that will still work. There's no reason why it won't. The thing is, though, is we have to intercept. We have to stop it from actually going to this endpoint where it's not going to find this thing, right? So we stop it. And once we can actually take a look at the request and say, okay, cool, what are you trying to do? Okay, so you've written a method. You want to access this method, right? Okay, cool, so we'll send you off to, where do you want to go? Oh, this resource? So we're going to send you off to this controller. And in this controller, we have this method. And we're going to call that method, and we're going to pass it these parameters that you fired off. And a lot of model view controller systems work that way. Actually, most systems with routing work that way. For example, this is Ruby. This is Ruby on Rails. This comes actually directly from the routing guideline. This is a table of the routes that they actually use, right? So you can imagine these as if they said SeanMcKinnon.ca in front of them, in every single one of them. So SeanMcKinnon.ca/resource, SeanMcKinnon.ca/resource/new, okay? And each of these have a certain, I don't know what the word I'm looking for is. Each one of these has a certain functionality to it, right? And they're using a common type of convention in order to do these things. So slash resource will actually bring back all of the items in that resource. Slash resource new will allow you to create a new resource. It'll give you a form where you can actually create the new resource. Obviously, new is only delivering the actual visual part of that. When you actually go to submit the content, you do post slash resource, and that will allow you to actually create this particular item. But notice the other two at the bottom here, patch and put, right? You have to actually pass those HTTP methods, and then that will allow you to update a resource, and delete will allow you to remove that resource. This is not written in stone. This is just Ruby on Rails. Laravel does it a little differently. It kind of reverses some of these concepts. It doesn't use new at all. It uses something else. ASP.NET, the one you guys are working in, might do it even differently. Are you guys doing routing? Have you written a route? You're doing MVC, aren't you?
There's one thing on the customer.
Like you have a customer's resource?
Yeah.
Yeah. And then when you go to access a different, like say you want to create a new customer, what's your address for creating a new customer? So like slash customers new? What is it?
It is all done automatically by scaffolding.
So your actual address location doesn't change? It stays the same? Is it a single page app?
We always give the new integer or primary key for every customers. So when we just create new, so it will give a new ID for that.
Right. So when you actually build your URL to go to that customer,
Yeah.
what does your URL look like?
I know.
/customer/create.
Yes.
So like this. Yeah, that's what I was thinking. Yeah. So most systems work like this. So the thing that's actually doing this stuff, the thing that intercepts this and stops it from going to an endpoint and actually interprets it is called a router. Most times they're called routers. Maybe ASP doesn't call it a router. But in Rails it's called a router, in Laravel it's a router. When we do the MERN stack, we're going to be using Express. It calls itself a router. So that's basically what helps handle this. And all the router is doing is listening for requests. So when you type in seanmckinnon.ca/resource, the router intercepts and says, cool, I've got that. Don't you go anywhere. Now let me go see what you want to actually access. And then it matches you up to whatever the functionality is that needs to execute once it's found that. So if I do seanmckinnon.ca/resource, it's going to take me to the resource controller, and it's going to execute the index method that's on there, which will wind up returning back all of the resources of that thing. Don't worry too much about this. This isn't necessarily going to be on the test. Sorry, let me rephrase that. This will not be on the test, that part, but it is important to understand. Even though there are several verbs, like I said, the most two common are get and post, which you guys should be used to using. Many frameworks do add support for put and delete. The mean stack will add support for that to create better semantics around an operation and enforce some conventions. However, vanilla sites are restricted to just the two verbs. You only get and post. And it's important to understand the differences between the two because get should be used for reading information only. So anytime you're retrieving information, you should be using get. Get should not create, update, or delete information, ever. Okay? Get request should result in idempotent operations, and idempotent means not modify the original value in any way. Okay? Now, I did make a mistake. Post actually falls under idempotent because it creates a new resource. It is not technically modifying the original resource because there was no resource before. So post should be used for creating, updating, and deleting data. And post requests can result in non-idempotent operations. So that's the idea. Get, when an operation is being used with get, it shouldn't be doing anything destructive. It shouldn't be creating anything or destroying or modifying data. Okay? Reliably, get should only ever request data at any point and not modify it in any way. It can mutate it. It can mutate it in a temporary state and return back that temporary state of mutation, but it should never actually affect the original. It should never modify it. Post should always be used when you're trying to create a record, update a record, or delete a record. And quite often when people teach this, they teach you to do create and update using post. So you guys probably created forms where you did create and update. But then you likely did a get request to do your delete. You had a link, you clicked it, and it removed the resource. Is that how it worked? Or did you create a form? Out of curiosity, how many of you created a form to delete the resource? Cool. So most of you created a link, right? You guys did CRUD, right? Okay. I'm just curious because we're not getting much feedback here. How did you delete your resource? So if you created a link to actually delete the resource, that is technically incorrect because you're using a GET request to remove the resource, which is not what you should do, right? However, unfortunately, that's what most people do. Cool. Now, there is one more thing I'd like to discuss, and that is the myth that GET is more secure than POST. A lot of people like to say this. GET's more secure. POST is more secure. Use POST, right? Because GET, you see everything in the address bar. This is obviously untrue. I showed you guys your post, like your GET request. I can also show you a POST request. I open up the little tab bar, right? And I can see in that application your entire POST request parameters. Neither one is secure. And when they're transferring through the internet, if they're on HTTP, which has no security protocol, there's no encryption between those endpoints, they are both vanilla text. Vanilla text traveling over the internet. Okay? So neither one is secure. The only thing that you may be able to argue is that POST is security by obscurity because you can't read it over somebody's shoulder. That's really the only security you get from it. Other than that, there's no security from POST or GET. Security only happens by using things like secure transfer protocols and stuff like that. We want to talk about cores? Yeah, I guess we should. So cores is cross-origin sharing. Basically, in the simplest of terms, cross-origin means you got an image, I want to access your image, but your image is on your website, and I'm trying to access it from my site. That is cross-origin, because I'm now jumping through the internet to go get it. It doesn't exist on my server, right? If it's on my server, that's same origin. In the last 2 years, there's been all these policy releases that Google has done and a whole bunch of others have done, and it now makes it very difficult for you to actually access cross-origin information. Images are still seem to be okay and not a big deal. A lot of text is, but doing an API call across the internet seems to be a lot more difficult unless the endpoint has given you authorization to do so. Because of that, the reason why I'm bringing this up, today's API that we're going to use has that same issue. But I love the API because it's so funny and it's so much fun to use. So what I've done is I've wrapped the API on my server and created routes for it, and then we're going to use those routes instead so we don't wind up hitting this issue. But if you try to access those API routes from another server, maybe you want to use it, you'll have to let me know because I'll have to whitelist your IP because of this, because of the cores issue. Okay. Cool. Why don't we take 15 minutes, process that huge amount of information, and then we're going to use the API so it can totally cuss us out. Cool. All right, take 15 minutes. I guess we'll start again. Okay, so now that we know a good chunk of stuff about the internet, I imagine it will take a little bit to process and gather that understanding, but at least it will help you understand more what's happening with APIs and that it's not magic. There's a reason why these things work, and hopefully maybe the internet doesn't seem so magical anymore either. You guys have done a networking class, haven't you? You're going to start to notice there's some comparisons to how the internet works and how your networking works, right? Because they are essentially the same thing. They're identical. Just one is external out to the world, and the other one is usually internal within like a network, right? An internal network. But I mean, once you understand that concept, understanding how to hook your machine to somebody else's machine remotely becomes a little easier because you can use those transfer protocols to do things like that. And so you definitely probably have a leg up on me because I've never taken a networking class, though I wish I would. I should, actually. But yeah, like once you understand the base concepts of networking, understanding how to control the internet and do really cool things with the internet, including stuff like AWS, becomes a lot easier. And if you have networking and you understand, you enjoy it, becoming an AWS certified builder or structure architect, whatever you want to call them, is really worth your time, because a lot of people pay a lot of money for AWS architects. And one of the core fundamentals of being able to architect those structures is understanding networking. It makes your life a lot easier in building those great big scaling infrastructures. So anyways, just keep that in mind. All right, cool. So we're now going to do an API. Now, just a bit of a disclaimer before we actually do this API. This API will insult you. It says horrible things, and you can put your name in it too as well, or your friend's name if you really want to be that kind of person, and it will insult them. However, I did create a path for those of you that don't want to go through that. It's called adjective, and it will just return back an adjective, a nice clean adjective. So if you don't want to do the insult part, just run the adjective part. Okay? Cool. So we're going to use something called the fetch API in order to do an API call. This is built into the JavaScript framework. If you're using Internet Explorer, you will 100% need to open Chrome, Edge, or Firefox, or Safari. Internet Explorer, specifically Internet Explorer, will not work. It's too old, right? It's like 2016, 2015, or something like that. It's too old, and it doesn't work with Fetch API. If you want it to work with the Fetch API, you will have to download a polyfill to make it work, which is a you thing, not a me thing. Otherwise, just use Chrome, Firefox, Safari, or Edge. Cool. So interacting with web-based APIs, made super easy with the fetch method provided by the JavaScript API. Before fetch, we would use something called XHR API to access our data, and XHR is a little bit more complicated to work with, though it does give you a lot more control over some other pieces of the request itself. But like I said, it doesn't work in IE. You can use the polyfill in order to get it to work in IE. Fetch utilizes something called the promise API. We are not going to get fully into promises today because they're a big topic, but you will be learning about promises in your advanced frameworks class, as well as async and await and how to utilize those. We haven't really talked a ton about asynchronicity in this class, mostly because it hasn't really come up. However, it's going to come up today. So remember how I told you in week 1, JavaScript is asynchronous. Asynchronous means that it won't wait around. It's not the same as parallel though, right? So we're not talking about multi-threading where 2 operations are happening simultaneously. We're talking about asynchronous, which means this operation is currently working and hasn't completed, so I've moved on to the next operation. Then when I'm done this operation, I can go check to see if this one is finished, and if it is, then I will execute it. Because of the asynchronous nature of JavaScript, it creates an issue that data is not ready when you think it's ready. Because this thing has not finished executing, so whatever it was going to return isn't available to you. So that's where callbacks come into play. Callbacks make things very easy because now you can basically say, once you're done, whatever it is you're doing, just do a callback and fire it off there, and I will work with the data at that particular point. Promises make it a little cleaner than doing just straight callbacks where we just pass the function in. And they make it just a little bit cleaner because instead of just a random callback, you get this dot then, so you kind of know when things are occurring. This is like promises wrapped. You're actually getting kind of abstracted away from the actual promise itself because it's in the fetch method already, so you don't get to see it. But .then is exclusive to promises. All right, so fetch takes 2 arguments. However, only one of them is required. The second argument is optional. The first argument is the domain, right? It's whatever the path is that you're trying to access. So it'll be whatever your API string is, and you can put it in there. The second parameter, which is options, even though it's called fetch and you might associate that with get, that is its default. However, you can tell fetch to do a post as well. So you can actually post data to an endpoint as well. So that first argument is your endpoint, wherever you are trying to access data from or send data to. The second is a argument of options, but we're not going to use that today. Just keep aware that it exists. After we've done that request, we create a then that is basically listening for a response back from our endpoint. Once we get the response, we have to decide what we're going to do with that. The response has a whole bunch of different methods inside of it. The one we want to work with is Json. However, it's a response stream, so it's asynchronous in itself, and quite annoyingly returns a promise. So we have to do another .then, because now we got to deal with this data. And then we can actually take the data, which will be the response.json, and we can work with it by doing a console log. Don't worry, it's confusing for the first little bit, but you'll get used to it. They're not very difficult. So we're actually going to build this using my favorite API, the Matt Bass API, which looks like this. These are the routes that I've given you. That's how they will be called. So the first one is the Matt Bass insult. You can see what it returns. It returns a JSON response containing an insult object. The second one is an insult and slash whatever name it is you want to use. So who is a parameter. So insult's the method, who is the parameter. Just write whatever name you want in there, or whatever you want in there. Somebody wrote on Monday JavaScript, because they guess they really don't like it, so they insulted JavaScript. This thing that does not care. And then the last one is the Matt Bass adjective. If you call that one, you won't get an insult, you'll just get an adjective. The worst it gets is like stinky or something like that. It's pretty tame. All right. Our possible API method routes. So keep those in mind. So right now, copy the one that you want to use. I'm going to copy the Matt Bass insult who. So copy the one that you want to use. All right, and then when you're ready, come on down here to where it says store your endpoint in a variable spelt incorrectly, and just do it as a string and paste it in place. There's no domain in front of it because it's local. Our actual API is local. That's just so I can get around the cores. I should just open it up so that anybody can query it. It doesn't really matter to me. All right, and if you chose the slash insult who, you're going to need to change who to a name. Make it your name or your friend's name. Or maybe your enemy's name. I don't know. Do you guys have enemies? Do you have nefarious enemies? No?
Sean.
That's hurtful. I like how fast I was able to guilt you. It's like almost instant. All right. Have we done chaining? We've done chaining, right? We've done commands that chain into other commands? Yeah, I think we have. Okay, so there's an issue with chaining that tends to catch people. So you can have your command, right? And then you can do dot your, so here's my command, dot tiny jog. My next command, right? Dot my next command. That's totally fine. I can keep chaining those. The issue lies in if I hit enter, right? So there's like a new line character in here, and then I do .n, that will break. And the reason being is because we busted up the chain, right? So the interpreter comes through and it's like, oh, dot, yeah, so you must be a part of the thing literally right above me. I will deal with that. Okay, enter, dot. Yeah, I got no idea. Don't know who you own, like who owns you, what you need to be doing. So it blows up and it tells you there's a reference error. So you can't do that. Here's where the confusion comes in. You can do this. You can have a comment between them, which is kind of annoying, but that's because the interpreter actually rips the comment out and collapses it. So these two things will read into each other properly. So you'll notice that I have step 2, step 3, step 4. I don't want your takeaway to be like, oh cool, I can use new lines in between this, because you cannot. They do have to be all connected or have comments in between them. Okay? Same thing goes with like else conditions too, and if. If and else work the same way. All right, so we're going to do fetch and pass it our endpoint. Do not put a semicolon at the end of it, or that definitely will terminate it. Then we're going to do .then. And we'll do it, I'm going to do it first the long, difficult way. So function, response, return, response.json. So I'll do these the long way first, and then I will flip them into arrow functions, and you can change them over if you want to. And then step 4, again a .then. Make sure you haven't used semicolons on the above two. .then, function. This one we're going to say it's called data. It can literally be whatever you want. That one can have a semicolon because we'll be done. And we're just going to console.log the data. All right. If you go ahead and click execute, the insult will appear, and you will notice a slight delay from when you click execute to when the insult appears on the side. It's probably so funny because this guy's probably like, once every like 4 months, I get like a whole whack of traffic, and then it just disappears. Because it's like 42 people on Monday and then 42 people today. And then it just stops. And then it's just this traffic count goes way down for another 4 months. We use MapAss's API in the other class too, in the advanced frameworks class as well. Only we do it with Node, and you guys get to learn how to set that up and everything. Okay, cool. Anybody still typing? No? Let's convert it to arrow functions. So this can actually be thinned way up with arrow functions, because this whole system, we can get rid of the word function. We don't need it. We need response, but we don't need this curly brace. We need a hash rocket. We don't need the word return because it's implied if it's only the one thing. And we don't need the semicolon, but we do need the other bracket. So there we go. That's that function compressed into a nice arrow function. Yeah, it's one. Well, so was the original. They're both lambdas. Yeah. Why, is that what it looks like in Java? Oh, cool. I didn't know. I'm not a Java programmer. All right, and then we can do the same thing with the other one as well. Just like tighten this up, get rid of that curly brace. Boom, you're gone. Bring this up to here. Boom. Nice hash rocket. We don't need the braces anymore. Bam. Nice and tight. And then when you click execute, you should get another insult. Shouldn't change. Just now it's all nice and compressed. So during your like 2 weeks that you're off, I would take a look at these like arrow functions and stuff, because when we do advanced frameworks, we'll be using them exclusively, like all the time, because we'll be using ES6 all the time.
Oh, really? Whoever wrote these insults is savage.
They're auto-generated. So you can actually, so that brings up the next point. If you click on the arrow beside your insult and you click on the args, you can see there's a template object there. And that's what he uses to generate it. And actually, Matt allows you to pass your own template object. So you can create your own template using his content in it, and then he will generate an insult based on your template. Which is pretty neat. All right, anybody still typing? Anybody's not work? Just didn't work at all? Lulu's, you didn't? What's that? response JSON looks correct. In promise, you're getting a reference there if data is not. Oh, yeah, because you wrote date and data. Yeah, there you go.
No worries. All right.
Fetch, super simple to use, really easy. All it really needs is an address, right? Once it has the address, it easily grabs back whatever the content is. And then these two then statements, that's all you really need. On your test, you will be retrieving an endpoint from an API. Just these 3 lines is all you're going to wind up needing in your question. So just keep track of that, right? So that you know how to do that.
Cool. So you will notice you have an object in our console, right? We saw that over here. If you ran one of the insult endpoints, you will see an object containing various properties and another internal object called args. Did anybody run just the adjective? Oh, you did? And does it come back with the same object, basically? It says insult, but it just gives you the adjective word? Right. Okay, cool. That's good, because the next step, we're actually going to take the insult and publish it into here. And if you did the adjective, you'll be able to publish the adjective into that. So I've copied your content. If you hit execute, I've copied your content, and I've already stuck it in the next block for you. So it'll be your exact code in that block. Okay? And then down here, there's some steps. So step 5, change the callback function of the last .then to be called put our response in. So just copy put our response in and replace this entire argument to just put our response in.
And incidentally, we're going to have to do one more step that Monday revealed.
There's an order of operations issue, which is really bizarre. Need me to scroll up a little bit? Step 6, add the data parameters so the function can have access to our data. So in the put our response in function, add in the parameter data. So that way the argument gets populated. And then the last thing, step 7, select and change the text content of the block to be our data, the insult if you've got one, the adjective if you don't. So that part, I'm going to give you a few minutes. I want you to figure out how to do that. You need to go up, select that block, and then you're going to replace the text content with your insult. Both those things you should know by now. We've done it a few times. So I'll give you a few minutes. You can work with each other. It's totally fine. Okay. I'll scroll down for those of you that are trying to see the screen.
So how can you tell what field to put that in? Like what our element is? How would we find our element?
Yep, exactly. Like Nestor said, you just right click, inspect. And I mean, I even wrote put response here. So it's like pretty easy to figure out which thing you're doing it in. And actually when you do that, you can double click this and it will highlight it. And then you can copy it. And then come down in your actual response down here. And we'll just say, we can actually do it in one line. Document.query selector dot, because it's a class. We can come down to the next line, do a dot and chain on our next piece. We'll just do text content down there. Text content equals, and what is our text content going to be equal to? Yep, data. Dot.
Insult.
Yep. Insult. You were halfway there. And now when you click execute, it's not going to do anything. You're going to get an uncaught reference. And the reason that is because I take your content and I store it in an object underneath the scenes. And for some reason, this stupid thing, because it doesn't get hoisted to the window object, it winds up out of order. So we actually have to take our function
and put it above our fetch. And then it will work.
I don't know why, but that seems to be what has to happen. So just copy your function, or cut your function, I should say. Come up above step 1 and paste it in place.
And then when you hit execute, it should publish your insult into the block.
And you can literally do it as many times as you want. Every time you do it, you should get a different thing. Sean McKinnon as craptacular as a disgusting anal deformed cloud of obnoxious annoying lizard excretions. A lot of stuff to do with butts in that one. What a nicer one. Give me a nice one. As an impertinent horse load of annoying vile lizard crap. Cool. Devastating, right? Like huddle in a corner in a fetal position, kind of devastating. All right, so now you should be comfortable with fetching from an API. I mean, it is not hard. It's literally 3 lines in order to do it. So what I've done, this is a lot cleaner. I've given you a really nice API to access. If you right-click and open it in a new link, you will see that it's this wonderful JSON object, right? And it's got a whole bunch of information. And get used to Bob's Bait and Tackle Shop, because in the Advanced Frameworks class, we'll be using Bob's Bait and Tackle Shop a lot for the whole class, pretty much. All right. So what you're going to do is you're going to take that. Your first step is to go through those steps
There, and basically what you're going to do is you're going to create an HTML template. Remember HTML templates? Vaguely? Okay, you're going to create an HTML template. You're going to, inside the HTML template, create a structure that allows you to add a SKU, a name, a weight, dimension, and price. So now you're going to have to access these things by accessing the elements themselves. So what I would do, if it was me, I would make those my class names, right? That way I can easily access those, plus publish the data in them just using the class name. Okay? Next, you're going to do your fetch API, right? I've created a variable up here called letCallback. You're going to do your fetch API. You're going to assign your template to the variable, so document.querySelector, whatever your template name is. You're going to assign a callback function to this variable. Clone your template, select and store the body, and then append the product to the body. So now you're going to want to also iterate over the product, and you're going to want to change, like add the data from the product into the clone, right? So your for loop will iterate over the products. Then you're going to add some styles. Then you're just going to show me your finished thing. I've also given you a style sheet right here that will parse your styles, and it works. It works quite well, actually. Background pink. Execute. See? Works. Inline. Ready to go. So go ahead. Work in as big a group as you want. I don't care if it's the whole class working all together at once. Doesn't matter. Just work together and see where you get in, what time is it? 8:30, 8:40? Yeah, let's see where we get in 20 minutes, and then we'll work on some of it together if we're really far behind. All right, give her a go.